So my name is Tomasz Turek, I work in Veeam, and what I wanted to tell you about today is what's going to be changing in the upcoming version 9. So today is kind of a what's new session for those of you especially who already know Veeam or who have been following what's going on with Veeam and just want to figure out what will be coming in the next release. If you are subscribed to our newsletters, for example, you might figure out that version 9 is not yet out. It will be available this year. We're expecting it to be early December or late November either. So one of the two, and then, of course, version 9 will be there. Just two very quick introduction slides. For those of you who don't know Veeam that well, we're a company founded in 2006. From the very beginning, we were focusing on a virtual environment. So in the very beginning, it was only VMware. Then we added Hyper-V support, just so we can actually equalize all those functionalities for both hypervisors. We are also a global company, so basically we are present on any market around the world. And when it comes to our portfolio, there are two primary branches that we take care of. One of them is backup, which is, let's say, our main area of focus. And the second one is monitoring, where we have two things available. One of them is our own platform, which is called Veeam One, and the second one is the management pack for System Center. So for those of you who are already using SCOM, this is a way for you to also utilize that framework to monitor VMware, monitor Hyper-V, and also have some additional backup enhancements. Just as a reminder of how the backup and replication, so our flagship product change, here's a little timeline. So the cool things, as I told you, is that we were focused on virtual environments from the very beginning, right? So we always decided that virtual environments are different from the physicals, and that's how we actually want to perceive them. So from version 9, it was actually both backup and replication, so nothing changed there. It was always trying to keep up with the technology as much as possible. Also, we tried to introduce certain functionalities that are, well, even today, considered to be a niche set of functionalities. So the biggest breakthrough from my perspective was version 5, when we introduced the vPower functionality, which we still use today. Of course, it was vastly improved. So with vPower, what it allowed us to do is to use the backup files for actual recovery process without the need of any production storages. So basically, we stream the data from the backup file and allow you to have the machines up and running in just a couple seconds. As of today, we have version 8 available for those of you who are using it. So with the version 8, of course, we added mostly the integration with specific hardware vendors, for example, so the ability for us to use storage snapshots for certain operations, which was further expanded in version 9. And one very cool thing called the Veeam Cloud Connect, I'm not sure if you know about it, I will talk a little bit later again about this functionality, which was also expanded in V9. So the features that we already know about, the features that I can tell you about what has been changing so far. So for those of you who have been using Veeam before, you know that Veeam is just a software. There's no appliance, there's no hardware associated with it. It's just a piece of software that you download, that you install on your infrastructure. Of course, it's very easy to deploy this way. The problem is when it comes to manage it, right? Because you have this single point of administration that you had to access. And this was actually one of the biggest drawbacks when it came to especially enterprise clients for us, because, well, in smaller companies, when there's one or two backup administrators, it was not a problem. The problem was when there was a whole section devoted to backup or devoted to storage, or maybe a separate replication section, which was still using exactly the same console. So in version 9, we introduced the standalone console concept, which allows you right now to fully separate the backup server role and the console itself. So right now, every single administrator can just install it locally, just have it available at the local machine, and can actually connect through a single port to the backup server pretty much anywhere in the world. So the good thing about it is that, well, first of all, you have everything installed locally on your machine, so you don't need to RDP yourself, you don't need to use terminal sessions to actually connect to the server. If the only allowance that you have is for 2 users to be connected at the same time, you also don't have this drawback of kicking out other administrators when they're actually working on the backup server itself. So it is an optional component, so for those of you who have well, Veeam deployed as of today, or maybe are deploying still version 8, nothing might change if you don't want it, right? So you can just keep the old architecture, it doesn't really matter. You can also very easily adapt to the new architecture once it comes out, right? Because the server itself will also automatically install a client on itself, so basically it's gonna work exactly the same. Plus, you have the ability to install additional connection clients pretty much anywhere in your infrastructure. So this is again something that you can very easily integrate into your infrastructure. So with version 9, as you will see further on, we actually try to move into enhancing the current features, into actually making everything simpler, more enterprise ready, so to speak, especially for the people who have different locations in their infrastructure. So the next set is actually improvement of the robo features, something that you might not be aware that actually works like it does as of today. Maybe you'll not even notice once this architecture actually changes. So if you know exactly how Veeam works, then you know that the backup server, even though it's basically just a management point, is also responsible for a couple operations. One of them is, for example, sending the request to quiescence virtual machines, right? Technically, does not sound like a big deal if it's just sending a request, but if you have a remote location that's housing a couple hundred VMs, every single one of those requests has to be sent to the backup server, and then the return message from the VM has to be sent back to this server. Not exactly the easiest way to do it, right? Same thing if you look at, for example, file level recoveries. Technically very simple. Practically, even though you're able to browse the files from basically anywhere, the file recovery option had to always go through the backup server itself, right? So even if you were recovering locally in some remote location, let's say a 2 terabyte database file, it had to actually go back to the backup server. It was physically then being recovered, and then it was sent back to the original location. So with this, what you're able to actually do is contain the locations to absolute minimum, right? So basically all the data movement can go within a single location. The backup server right now is truly going to be simply a management component for your infrastructure. And also because of that, you don't really have to take into account the connection between the location, also how those components have to interact with one another, again, because you can do everything within a single location. And just like with the remote console, don't worry about the architecture. By default, we're gonna change pretty much everything for you, so it's done locally, it's simply done faster. If you wanna switch it back to the old mode, of course it's gonna be possible. If you wanna further expand this kind of functionalities, you can of course also do it. So, as I told you, if you were quiescencing VMs, what was actually happening is that the backup server was sending a request to the hypervisor on the other side, and then to a specific VM. Okay, let's, for example, do this VSS snapshot. So the VSS snapshot was, well, either happening or not happening, and then we got the message back. Is it okay? Is it not okay? If it's okay, we send the data back to the backup server, and then we start talking to the proxy. Okay, start the backup, right? Again, not really optimal. With version 9, we're going to introduce the concept of guest interaction proxies. So right now what's going to happen is that the backup server only once will send info to the guest interaction proxy. Okay, we're starting this backup task. And now everything will happen locally. So this guest interaction proxy, so here's the one-time messaging. This guest interaction proxy will actually start talking to individual VMs, right? So all the data movement is actually within this single location. If you're backing up just a couple VMs, you will not see an improvement. If you are backing up a couple hundred VMs, for example, this will be pretty big, right? In terms of the time it takes before the actual backup starts, right? Because there's always this preparation time where you make sure that you have enough resources to run the backup, where you query the infrastructure, is everything there, is everything accessible, and then you wait for the quiescencing option itself, right? So this will simply improve this process and possibly cut down your backup window. The second thing, as I told you about, is the file level recovery option. So what it used to look like is that if you wanted to recover a file from this particular location, well, the file, in order to be read by us, had to actually be streamed to the Veeam backup server. Of course, it was not recovered as a whole, because this would not make sense. But if you recovered an individual file, it would go like this. So it goes to the Veeam Backup server, that's when it's actually extracted, and then it's sent to the specific VM. Again, for little files, for a low amount of files, no problem, right? If you're recovering basically almost an entire VM on the file level, if you have some data disk that you want to recover as a whole, or if you're just recovering a huge, for example, database file, you would see what's wrong with this, especially if this connection in here is, well, slow, it's a one connection, it's not something that's optimized for sending large amounts of data. So the very similar thing to the guest interaction proxy is introduced. We call it the mount server. So right now, this mount server actually translates the backup file on site, right? So basically, if you recover anything right now, we mount it locally to this server. And from the VBR server, all we do is just manage, okay, recover this file, recover that file, whatever. The file recovery takes place here and is sent to the specific virtual machine. So again, everything is done on site. So those are just like two architectural changes, the console and those robo feature enhancements. But from the perspective of you guys, if you have different locations, if you have disaster recovery locations, it should improve your recovery times pretty significantly. Then moving on, in terms of the explorers, you know, we do have 4 explorers as of today, for Active Directory, for SharePoint, for SQL, for Exchange. For those of you who have not used Veeam before, an explorer is a way for us to extract application data directly from the backup file and then either export it or send it back to a production server. Not necessarily the original production server, but basically any production server that you have in your infrastructure. Now, the cool thing about the explorer is that, well, actually, there are 2 cool things. First of all, it does not require an agent at all. Right? So all we are doing is we're actually using VSS only to understand the content of this particular VM. And if we know, if a VSS writer actually responds, okay, well, there's a SQL writer present there, we already know that there's a SQL database there and that we can perform object level recoveries from this particular VM. And then you can see all the mounted databases, you can do point-in-time recoveries, you can even go back to a specific transaction. So this is the first thing. Second thing, in order for the Explorer to work, it does not actually require application consistency, right? So even if you do a simple crash consistent backup, for example, of your Exchange database, it's still gonna be recoverable on this item level. It's not gonna be fully automated because we don't know that Exchange exists there, but what you actually have to do is point us inside this backup file to, for example, an Exchange database, the EDB file. And then the EDB is mounted. You can see all the mailboxes, all the emails, attachment, contacts, calendar events, anything. So with this, technically, even if you don't have a virtualized component, but for example, you have a physical Exchange server, if you can just show us the EDB file, we can still use it, right? It does not have to be a Veeam backup in order for us to actually allow you to recover individual items. So of course, the current explorers will be enhanced. There will be some additions as for the recovery speed and some recovery functionalities. But the biggest thing that's coming in V9 is the Explorer for Oracle, right? So it's gonna work pretty much the same as it does right now for Microsoft SQL. So with the Explorer for Oracle, as I told you, it's gonna work pretty much as it did for SQL. So what's gonna happen is that the idea is you create a regular image backup of your database server, for example, once a day, like for example, every evening. And then every 5, 10, 15 minutes, however you define it, we can actually connect to this Oracle server, get the archive logs, and send them to a Veeam server. So that way, not only you have the full server that you can recover, not only the database level recovery that you can perform, but because we can also extract those archive logs, we can do point-in-time recoveries, and we can actually go back to a specific transaction if you know exactly what broke your database. So point-in-time recovery is not granular enough for some people. You can actually read exactly what's been going on in this database, choose a specific point, and we're going to recover the database to the latest point before this particular operation actually happened, right? Again, the cool thing, it's actually fully agentless from our perspective. You don't install anything on the Oracle server itself, only just a couple minutes. Every couple minutes, we simply connect to the server. We just inject a runtime code. It uses native Oracle commands to actually drop the logs, send them to the Veeam server. And if you're using ASM, of course, this will also be supported. And the second thing about this Oracle Explorer that's new for us in Veeam in general is that it's also going to work for Linux distributions of Oracle. If you look at the previous Explorers, because those are Microsoft apps, they only basically worked for Windows. Right now, if you have Oracle on Linux, if you have Oracle on Windows, we can actually use both of them and protect you from all the angles, right? So this is going to be pretty cool for those of you who are running Oracle. Does anybody here have Oracle in production? Yeah, just like 1 or 2 people, but still, hopefully you'll find it actually useful. So another thing that changed, if you, again, remember Veeam, if you remember how we started just a couple years ago in this region, there was no tape at all, right? Because we were a fully virtual solution, we decided that, well, tape, it's not really that useful for virtual environments. It's slow, it's sequential, not gonna happen. So of course, a couple versions later, we had to add tape because so many people actually kept using it. So tape support is already there. And with version 9, we try to expand this support just to make it simpler for you to actually manage your tape infrastructure. So a couple things that will actually be added to this pool of functionalities that we already have. Something called the global media pool. Because if you look right now, what's happening is that if you create a media pool in Veeam, you can basically attach it to like a single library, right? So it's one media pool, one tape library. Not exactly useful if you have like tens of libraries present at your infrastructure. So right now what you can do is create a media pool that's gonna span across all the tape libraries in your infrastructure. And of course, those can be regular tape libraries, those can be VTLs, doesn't matter from our perspective. So that way you can just basically offload the entire workforce of the process of writing to tape into all the tapes that you have in your environment. Second thing that we're gonna add is parallel processing. So again, if you look at it, one media pool could write to a single drive at one moment, right? From our perspective, it used to be enough because from virtual environments, either you didn't have that much data to actually write to tape because you mostly use disk-based storage because of some recovery functionalities that we have, but because it's not performance-wise optimized, we had decided that, well, right now it's possible to actually write to as many drives as you want at the same moment. Again, just to simplify the whole management process of your tapes. GFS media pool retentions. If you're using Veeam already, you know we have something called the backup copy jobs, and with the backup copy jobs, there's a checkbox to use the GFS retention. So what this basically means is that aside from the regular backup chain, all the weekly, monthly, yearly, quarterly backups can be simply set aside for archival purposes, right? So those are just basically your additional copies, full copies of all your data that you have, just stored in case something happens. Of course, you have a regular chain. Let's say it's gonna be, for example, let's say a month, right? So every month, I mean, the latest month on the every single day level. Then, for example, the latest month, you also want additionally on a weekly level. So you create 4 weekly copies. Then, on the yearly perspective, you want a monthly backup, right? So every single month, you'll have an additional copy set aside for archival. And then for another 5 years, you want a yearly copy. So every single year, we're gonna put aside another one. So this is what used to happen for backup files. Right now, it's also gonna happen for tapes. So if you're offloading tapes, if you're just sending them to some safe in the offsite location just to be stored pretty much forever until they expire, this is actually a simple way for you to do it. Technically, you could do it before, just playing around with our scheduler. This will simply simplify the process for you. And the second thing, it's actually a small one. If you had a problem that your tape device was not recognized by Windows operating system, right? Because for us, in order to use the tape, it has to be recognized in the device manager of Windows. Not all vendors provide drivers that actually are correctly recognized. So right now we are actually able to use those drives simply by failing over to native SCSI commands of those tape drives. Right, so it's not gonna be, let's say, as sophisticated in terms of using this tape, but if you had a choice of not being able to use the tape at all because Windows doesn't see it, to using some basic functionality, writing, reading, stuff like this, basically we are giving this for you from our side. So the global media pools, just very quickly, as I said, you can span everything across multiple drives. So in case, again, something goes wrong, so for example, you lose a library, you lose a specific drive, the other ones can actually take over the process and simply continue your retention policy. So in case something goes wrong, you're simply protected on this angle. With parallel processing, as I said, if you have a couple jobs, for example, here you have a single pool, 2 jobs inside this pool, and you wanted to write them to tape. Beforehand, it would be like, okay, so from this pool, we can just write this job, and this one would have to wait. With version 9, everything gets written as long as there is a drive already present and free that we can actually utilize. So again, it's going to cut down your backup window, I would say, pretty significantly if you're using tape devices. GFS. So, as I said, weekly, monthly, yearly backups can be simply offloaded. You can just specify particular tapes with predefined retention on this GFS level, right? So, for example, if you have a weekly copy, well, of course, the retention level is going to be on a weekly basis, right? So we are actually going to start managing those tapes on our own. So technically, as it says right here, for 4 years, you're going to need approximately 19 tapes, and we're simply going to rotate those tapes just to keep all the drives, all the data as compact as possible within all those tapes. Of course, this is just a conspec because probably during 4 years you're going to have to replace some tapes, but this is basically the idea that we're going to use. And failing over to the SCSI commands in case your tape drive is not recognized by Windows. Another thing, this is actually something that came up thanks to NetApp, because when we added NetApp support, NetApp is heavily relies on NFS, right? So they have a pretty cool NFS client, it's actually pretty good in terms of performance. What we wanted to do is that because we already have a direct SAN access, so you can connect everything through fiber channel, because we can use hot-add, because we can use the regular network mode, why not integrate with NFS arrays as well? We tried a couple NFS clients that, well, we saw on the market. Unfortunately, none of them were great. And we wanted to avoid a situation like this, that if somebody has an NFS storage, all the data first has to go to the host and then to the Veeam component. So what we did is we actually wrote our own NFS client. And right now, what we can do is, well, you can call it a SAN-based backup through NFS, right? So we can talk directly to the storage array without the interaction of the ESXi host. So it's going to put less load on your production environment, and of course this process is going to be faster because you don't have this man in the middle that has to manage all the storage movement. So for those of you who try it, it's going to look like this. If a backup is happening, there is a new option. There used to be SAN, hot-add, or NDB. And right now, you also have NFS. So basically, just like a direct SAN access, but for NFS. Again, gonna make everything pretty fast. Does anybody have HP store onces? Not really. Okay, I'll just mention very quickly that in version 9 we're going to support Catalyst. So if you have store ones, or if you maybe are planning to get store ones, we can actually use Catalyst right now to simplify the process of writing the backups to the deduplicating storage. So basically, Catalyst is going to do source size deduplication. So basically, it's going to pre-deduplicate all the blocks that should be written to this array. So thanks to that, the backup process itself will be a lot faster. But this is not the biggest thing. The biggest thing is that if you were trying to create a synthetic full, do you know a synthetic full in general? So basically, it's reading the blocks from the entire backup chain to create a full backup file without the use of VMware, without the use of Hyper-V, whatever. We're just simply working on the storage itself. We're just taking all the data from previous backup files and creating a full backup file that you can actually relate to. Why it's called a synthetic full? Because it's not actually using your virtual machine data. So this process on the deduplicator was quite horrible because you had to read all the blocks from the entire chain. You had to create a new full backup file, you had to write this full backup file, and then it had to be deduplicated. So previously, what it basically looked like, not sure if you can see it, the process for a 100 gigabyte VM in here took like 6 hours, 40 minutes, like for 100 gigabytes, which is actually pretty horrible. With Catalyst, the same operation, because technically right now it becomes a logical operation. We're just working on the pointers right now. It's gonna take you like 20 minutes, and that's pretty much it. So if you're using a deduplicator, if you're actually archiving your data on a deduplication device, this is actually a very good way for you to go. Just keep in mind one thing. We did not add this before, even though we had a relationship with HP, which was pretty good, because the previous version of Catalyst was not really doing great with random I/O. So it was great with the sequentials, not really with randoms, which we use a lot of. So because they rewrote Catalyst, we were able to actually integrate it into our architecture. But this is the piece of software that HP will probably release along with our version 9. So it's not the version of Catalyst that you have available right now. So if you want to use it with version 9, just make sure to update your HP storage. Another thing, again, small architectural change, it's something we call SOBR. So it's a Scaleout Backup Repository, something that we also introduced in version 9. It's actually just for managing so for easily making the management of data easier, and also just for the people who have different backup storage arrays, so to speak. Because previously, if you look at a Veeam Backup Repository, what does it used to be? One repository was basically one folder where you could store your backups, right? So it was basically like one location in your array. With the Scaleout Backup Repository, what you can do is you can actually create many repositories and simply treat them as a big jar to which you can write, right? So for example, what you can do easily then is simply, if you're running out of space, instead of expanding the disks or buying new disks, you can just add a new location, a new disk, add it to the Scaleout Backup Repository, and then you can just continue running backups. You don't have to really worry about reconfiguring your current infrastructure. Second thing you can do is, for example, if you have deduplication storage and you have some regular storage, maybe put the full backups into a deduplicating storage and run the increments on a regular storage, because it's simply going to save you a lot of space, plus the incrementals will still be run on a pretty fast piece of storage. In order to utilize the Scaleout Backup Repository even further, we also introduced the per VM backup files. If you look at a backup file today, even if you have like 100 VMs, the output backup file is just one thing, right? It's going to be, for example, a VBK, so the full backup. Not really easy to manage it, to move it around. With version 9, it's optional. What you're able to do is that for every single VM on the repository, we're going to create a separate backup chain. So this time, right now, you can actually choose a performance policy, for example. So for example, if you have 5 different repositories on 5 different storages, so the full backup for the first VM goes to the first storage, for the second VM to the second, for the third to the third, so on, so on. So basically all storages are used pretty much with the same amount of performance put into them. And then all the incrementals gets simply distributed between those repositories just to keep everything running as fast as possible. So right now it's just not it might not be a more sequential type of stream. So for example, you just write huge backup file to a single repository, but everything can be utilized virtually at the same time. Further on with storage integration, if you know, again, how we do it today, we do it with HP, we do it with left hands, we do it with 3-parse, we do it with NetApps based on ONTAP. In version 9, we're also going to do it with EMC, VNXs, and VNXEs. So what we're actually trying to do with this is that instead of only using the VMware snapshot to copy the data, which is not the optimal way because it grows, right, and then you have to commit it at the end of the task, we're actually also helping ourselves with the storage snapshot. So what's going to happen, instead of creating a regular backup, maybe I will see it right here. Yeah, instead of creating a regular backup, so you create a VMware snapshot, and then you copy all the data and then remove it, which takes time. The snapshot grows. It takes you a lot of time to actually commit it. What's going to happen is that you create a VMware snapshot only for quiescence reasons. Then you create the storage snapshot, and immediately you commit the VMware snapshot. So from VMware perspective, the backup is going to last like 5 minutes, for example. And then we talk directly with the storage array without even touching your virtual infrastructure. So it's gonna make your backups actually go quite a lot faster, and your production VMs will be a lot less stressed during the backup process itself. So as I told you, VNXs, VNXEs, through fiber channel, through iSCSI, through NFS, basically however you have them connected in your infrastructure. And along with that, for VNXs, for EMC in general, we're going to add this VM Explorer for storage snapshot capability that we already have. So if you don't have time in the middle of the day to create a backup of a specific VM, because it of course takes time, what you can do is simply create a storage snapshot of the entire volume. Because we understand the storage snapshot from this volume-based snapshot, we can get individual files, we can get, for example, application items, we can get the entire virtual machine. So technically, without creating any Veeam backup, by using just the storage functionality, we're able to recover individual items or an entire VM directly into your infrastructure. So this is again pretty cool if you don't have time to create backups, or if you simply want to base your data protection policy on both the backup files themselves and on storage snapshots, for example. And the last thing we want to do with storage snapshots is we also introduced a sandbox environment for those snapshots. We used to have this for regular backup files. We used to have it for regular replicas. Right now, if you have a storage snapshot, we can actually boot up VMs from the storage snapshot inside an isolated network environment. So you simply can use it as a lab environment for yourself. Right now, we don't really care about if this machine is recoverable, is it fully consistent, because it's a storage snapshot, right? By default, it's not going to be application consistent at all. But it's a very simple way for you to create a testing environment from the infrastructure that you already have present, right? If you created a storage snapshot, for example, yesterday, and it's still lying on the storage because you have such a policy, use the storage snapshot, right? Boot up those VMs in this isolated lab and simply see, okay, can I reconfigure this VM? Can I put some new version of my software onto this VM? Can I maybe do some troubleshooting? Whatever. Because this storage snapshot is in read-only mode, if you break something, just turn off those VMs, just redeploy the lab, and that's pretty much it. So you don't need any additional hosts. You don't really need anything, well, aside from the infrastructure that you already have available. And as we said, HP, NetApp already EMC in version 9. And I think it's one of the last things I wanted to talk about, and a cool one, Veeam Cloud Connect. Have you heard of this functionality before? So Veeam Cloud Connect in version 8, so basically what we have today, is a way for you to utilize a partner as your disaster recovery location for the backups, right? So for example, let's say this is you, right? So you have some VMware infrastructure, for example. You have some production storage. You create your backups locally. You don't want to create a disaster recovery location. You don't have the budget, or maybe you just have a company that you are working closely together with. And this company is our partner, so they're a cloud provider for this Cloud Connect functionality. So what's going to happen is that this cloud provider creates a Veeam backup repository, which you can actually see locally in your infrastructure, right? So then you can, for example, create your local backups onto your production backup storage, or however you want to call it, and then as an offsite location, you simply choose this partner repository and you send it, for example, to Atea or whatever, right? So they're basically your disaster recovery location. Those backup files can be encrypted, so they're not able to recover them easily. You can basically do anything with them. And this was in version 8, so basically just backup files that were basically giving you storage as a service, like a Veeam repository as a service. In version 9, we also added replication to this. So right now, if you not only want to send just the backup files, you can actually send entire VMs to their infrastructure. So right now, instead of just giving you a piece of storage, they actually give you a piece of their VMware or Hyper-V for that matter infrastructure. So how this actually works from our perspective, maybe I can try to enlarge it. you have your own regular infrastructure and you use replication to the partner location. The cool thing is that you do it, you connect to something called the cloud gateway, and because you're not physically copying data like between vCenters, so it's not like a VMware regular replication, it's not like migrating, not like a vMotion between vCenters. This works over a single port, right? So there's just one port you have to open, and it's all wrapped in SSL. So basically this channel is also encrypted. So in case something happens, you know that the data is fairly safe. So the second thing, now what you can use this functionality for. If something goes wrong in your infrastructure, like for example, you lose everything, there's a fire, flood, or whatever, there is a web-based portal with a huge button that says failover. If you click it, all those VMs actually are booted up in the partner infrastructure, right? So basically you have your full environment present in their location. If you have a problem with specific VMs, so for example, 1 or 2 VMs that are critical for you have stopped working, you can just do a partial failover. So 1 or 2 VMs simply boot up in the partner location. In order for us to make this possible, so we introduced the concept of a cloud host. So what the partner actually gives you is just a set of resources. It's not a dedicated host or anything like this, right? So for example, he can give you like 30 gigahertz of CPU, 128 gigs of RAM, maybe 1 terabyte of storage, and some network connectivity. So basically, you just send the data to a hardware plan. But the problem is, if especially you do a partial failover. So for example, you failed over 1 or 2 VMs. What's up with networking, right? You have some local network, and then you have a partner. Well, he probably has a completely different networking system than you, and you still want to be able to access those VMs. So we created something called the Network Extension Appliance, which is actually created on both sides. So what happens right now if you lose, for example, this VM? Let's say its address is like 10, 10, 10, 25, just as an example. You lose it, and this VM gets booted up on the partner infrastructure location. Of course, it's gonna have a different IP address, right? Because the partner might have a different IP addressing policy or something like this. But because you created this network extension appliance, if from some different VM in your infrastructure you ping this 10, 10, 10, 25, we know that it should go through this network extension appliance to the network extension appliance on the target side, and this one knows it's actually this VM, right? So you can actually use local IP addressing that you used to use in your infrastructure to connect to the VMs on the target location. So basically, it's like software-defined networking that we created just for this replication process. So right now, even though those are two totally different locations, you can actually connect between one another as you would do simply locally. And the cool thing about it is that it's not an additionally licensed feature from our side. So all you're actually additionally paying is what you're renting from the partner. So if they are giving you, for example, 20 terabytes of storage, well, you have to pay for the 20 terabytes of storage that they give you, but from our side, it's already included, right? So it's in every single edition that you're gonna have, and the only requirement is that you need version 9 in order for replication to work. If something more makes it to V9, you can always subscribe to our newsletter just so you get the information as it comes. If you're just waiting, for it to get released, if you already know everything, as I told you, it should be approximately a month until it gets fully out on the market as a general availability. And the last thing I just wanted to talk about, if you are using Veeam already, or maybe you just have some lab locations, if you have some laptops at home, maybe some smaller infrastructures, we have quite a lot of free stuff that you're very welcome to use. There's the Backup and Replication free edition, Monitoring free edition, and my favorite, actually, the Endpoint Backup, which I'm also using on my laptop. So if you have a Windows-based workstation, either at home, at work, it doesn't matter, feel free to use it. It actually does compression, does the duplication, allows you to recover individual files, does full bare metal recovery, allows you to do an entire machine-level backup, individual files, individual volumes, pretty much anything. And it also integrates with the repositories of your Veeam Backup and Replication infrastructure, just so it's actually easier to manage everything. And this one is a free product, so feel free just to try it out. Pretty cool to actually use that. Thank you very much from my side. That's what I know about version 9. Hopefully, closer to the release date or after the release date, I'll be able to show you also a demo how everything works, how those functionalities hopefully will change your infrastructures. That's it. Thank you very much. Okay. You can do it. By default, it's turned off because we want to keep it fully separate, but you can actually do it. You can define a static root inside the Veeam interface. You can define a static root between a specific VM in the sandbox and a specific VM outside of the sandbox. So then they will be able to communicate, but only those two VMs that you specify. Of course, you can do more relationships, but as I told you, by default, it's turned off. But you can just select a checkbox and it should be okay. Any more questions? Thank you very much then.